Hey guys, trying something a little new today. So I am on Google Meets recording this. I'm going to try and switch between the video, the document camera, and Desmos because I really need to show you how to do a lot of this on Desmos. So bear with me. You're welcome to watch this as many times as you need to. So I'm going to go ahead and present my screen now. Sorry if it looks a little weird for a little bit. Today we're going to be learning about standard deviation. And this is classwork 4.2 for my Math 1 folks. Standard deviation is how far are generally the data points from the mean or the average. Remember, mean means average. So there's two kind of big ones we're going to see here. It's the measure of variation. This one's not as widely used, but just in case, I wanted you guys to know what it meant. It describes how the data in a data set are distributed. How they are distributed. And then standard deviation, it's used by this lowercase Greek letter called sigma, is a measure of how far the numbers in a data set differ from the mean. Deviate is the actual technical term, so I'm going to put deviate in here. That's why it's called deviation. But that means how far they differ from the mean. And remember, mean meaning average. So we're kind of going to jump in with our first example. What are the mean, variance, and standard deviation of the following values? So you have 1, 2, 3, 4, 5 values up here. We're going to be putting these into Desmos because I'm going to be really honest with you. The math that goes along with this is very tedious and unnecessary when a graphing calculator can do it for you. So I'm not even going to teach the formulas behind this because it takes extremely too much time. And Desmos or your yellow calculator will do it for you. So we need to find the mean, the variance, usually known as var, and the standard deviation. I'm going to use the sigma here so you can get used to seeing that. All right, so now I'm going to switch my screen to Desmos. Hopefully we can get Desmos up here switched. So now that we're on Desmos, we're going to, like we did yesterday in the video, we're going to create a list. So L1, remember I put it in brackets, and the numbers are 6.9, 8.7, 7.6, 4.8, and 9.0. I highly suggest making sure you pause the video at this point and put these into Desmos. You want to practice this as I'm doing it. So like I said, we have 5 numbers, and there's a list of 5 right here. So like yesterday, I told you we're going to be using those stat functions here. There are a lot of different stat functions, but this STDEV is your standard deviation, and the var is your variance. So let's start with our mean, and you can just type mean, or you can actually press that button if you want to. And we need the mean of list 1. And the mean of list 1, it shows you on the screen, is 7.4. So we're going to just put 7.4 here. This is the wonder of Desmos. And if you guys want to see, I just put that onto my paper. So do the same on yours. The wonder of Desmos is Desmos calculates it for you. So now I'm going to do the variance, or var, of L1, and it's 2.825. And generally, when it does have a finite decimal like that, we want to write the whole thing. So I just wrote it on my paper. Make sure you write it on yours. And lastly, a standard deviation. Remember, it's STDEV and L1. And that's going to be 1.68. We are going to round this one. That decimal is way too long. So I'm going to change this equal sign to an approximate sign. So I know it's approximately 1.68. Now I'm going to go back to the screen. You can see that I wrote those down. And really, that's the basic gist of doing this in Desmos. It's pretty simple. Now, we're going to look at questions that can follow up on this. So example 2. The table displays the number of U.S. hurricane strikes by decade from the years 1851 to 2000. So here are the strikes right here. And that's going to be our list because the decades are important, but they don't really help us know anything. So make note of that list. We're going to put it into Desmos. We need to find the mean and standard deviation of this data set. So you can exit out the other ones if you want to, like I'm doing now. And then I'm just going to erase this list and put a new list in. It's 19, 15, 20, 22, 21, 18, 21, 13, 19, 24, 17, 14, 12, 15, 14. And I know you guys are like, wait, there was 14 hurricanes in 1 year. No, these are U.S. strikes in a whole decade. So in 10 years, there was 14 strikes. And if you look at the decade, if we go back to our screen, if you look at the decade, there's 15 decades, so we should have 15 numbers. Going back to Desmos, we have 15 numbers. So now the question was, we need to find the mean. So again, I'm just typing in mean and L1 because that's my list 1. If I had multiple lists, I would name the next list list 2, list 3, so L2, L3, and I could find the mean that way. So the mean of this one is 17.6. And I'm just writing that on my paper so I have it. And then the other question it had was, what is the standard deviation of L1? And that is 3.64. It is 3.64. So if we go back to our paper, we found the mean and the standard deviation. Within how many standard deviations from the mean do all the values fall? Okay, well, let's look at this. We need to find the highest number and the lowest number. So we can do that by looking at this, but remember on Desmos, we can put min in to get the lowest number, and it's 12. And we can put max in to get the highest number, and it's 24. So all numbers have to fall between 12 and 24. Between 12 and 24. So looking at this right now, if I start with 17.6, and it's my mean, so I'm putting it in the center, and I add 3.64, I get one standard deviation away because it's one time that I'm adding 3.64. And 17.6 plus 3.64, getting out my yellow calculator to do this. You can do this on Desmos still. You can just put this into the Desmos and it'll do it for you. Is 21.24. So my one standard deviation away up is 21.24. But since 17.6 is in the middle, we also have to subtract it to find the lower end of this. So we're going to do 17.6 minus 3.64. And I get 13.96. Now, are we at 12 and 24 yet for these? We're not there yet, so we're going to have to do it again. So I'm going to add another 3.64. So right now we're one standard deviation away from either side. So now we're going to do it again on both sides and see if we will get it between 12 and 24. So now I'm going to take 21, 24 and add 3.64. And this time I get 24.88. And then I'm going to take 13.96 and subtract 3.64. And I get 10.32. So now, do all the numbers from 12 to 24 fall between 10.32 and 24.88? Yes, they do. And how many standard deviations are we away from the mean? Well, we're one standard deviation away, two standard deviations away. So we are 2, and I'm going to abbreviate SD, standard deviations, away from mean. Now, it looks like there might be 4, but we always do the upper and the lower. So this is 2 standard deviations away. This is 2 standard deviations away. We don't add them and make it 4 standard deviations away. So now we want you to try. So find the mean, standard deviation, and variance. That's the VAR. So we're finding the mean, standard deviation and variance, and seeing what we can find there. And then it says within how many standard deviations of the mean do all the data values fall. So let's check this out. Going back to Desmos, I'm going to exit out of all of these. Again, please practice this yourself before you watch me do it. So if you need to pause the video, please do. I'll let you look at those numbers again. You also have this as a copy in the classwork for today, but there are those numbers again. Pause the video and try this yourself. All right, so those numbers are 12, 17. Oops, I'm not writing in there. 12, 17, 15, 13, 9, 10, 12, 10, 15. If you guys can't tell, my dog's here and going nuts though because my mom just got home. I'm visiting my mom for a couple days. So now that we have that, you have 10 numbers. Make sure you have 10 numbers on your screen. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's find these important numbers. So first we're going to find the mean. Remember, type in mean and then L1 because this is our first list. And the mean is 13. Make sure you write that down. Next up, we have standard deviation. So STDEV and then of L1. And that's 2.91. You guys might be wondering why I rounded to 2.91. It's because it's 2.905. And the 5 after that 0 means I'm rounding up to 1. And then lastly, we're going to do the variance of L1. And that's 8.44. Remember, the variance describes how the data in the data set are distributed, specifically about the mean. So the second question in this asks, within how many standard deviations of the mean do all the data values fall? So we need to find our minimum and our maximum. Let's find our minimum is 9 and our maximum is 17. So I'm going to come back to our classwork for today. So between 9 and 17, we're going to do the same thing where we start with the mean in the center, and then we're going to add 2.91 and subtract 2.91 and see where we are within one standard deviation. So when we add 2.91, 13 plus 2.91 is 15.91. When we subtract it, we get 10.09. So I added and subtracted from the mean. Are we between 9 and 17? Not quite. We're at 10.09 and 15.91. So we're going to go one more standard deviation on either side. And when you do 15.91 plus 2.91, you get 18.82. And when I take 10.09 and subtract 2.19, I get 7.9. So now, between 7.9 and 18.82, do all our numbers from 9 to 17 fall in there? Yes. So how many standard deviations away are we? Well, we're 2 standard deviations away up and 2 standard deviations away down. So in total, we are 2 standard deviations away from mean. Do you see a pattern here? And we're going to see on the next page that there's a reason why 2 standard deviations away from the mean is the norm. All right, looking at this question, this is an EOC prep question. So you want to answer the following end of course question regarding standard deviation. So the table below shows different states with different areas in thousands of square miles. So like Connecticut, this would be 6,000 square miles. Georgia, this would be 59,000 square miles. It's not just 59 square miles. So Delaware has an area of 2,000 square miles. Which is true if Delaware is included in the data set? So I'm going to add Delaware here at the bottom. And if it has 2,000 square miles, that means I put a 2 right here. Well, let's look at what we notice about 2 compared to the rest of the numbers. it is lower than every other number here. So it's lower. It's going to affect everything on the low end. So does the mean increase? Well, if we add a number that's lower than everything else, the mean's not going to increase. It's going to decrease. So it will decrease. This A is wrong. The range is going to decrease. Well, originally the range was 59 minus 6, which is 53. Now it's 59 minus 2, which is 57. So it increased. Can't be that one. The interquartile range decreases. We might not know what that means yet, but it does have to do with the range. So if the range increases, generally the IQR or interquartile range also increases. So it can't be that one. And last but not least, the standard deviation increases. When we bring in a number that's significantly different from the mean, and 2 is going to be significantly different from these numbers because it's the minimum now, it is going to increase the standard deviation because it's going to spread out that data even more. Now, if we had a number that was within this data set, that's not spreading out the data anymore. But this one's outside of that data set, so it did spread the data out more. All right. We're going to go to our next page, and we're going to talk a little bit about normal distribution. Normal distribution is data that vary randomly from the mean in a pattern of a bell curve. As you guys can see, this is called a bell curve. And looking at everything that we're dealing with right now with the coronavirus, a lot of what they're saying with the peak of the curve is based on the bell curve model. So in a normal distribution, 68% of data fall within one standard deviation of the mean. So 34% below and 34% above, that adds to 68%, are within one standard deviation of the mean. 95% of the data fall within 2 standard deviations of the mean. That's why we kept getting that data was within 2 standard deviations on the previous page. And then 99.7% of the data, which is a huge significance, fall within 3 standard deviations of the mean. But after this, it becomes really self-apparent of how to answer these questions. The mean is that middle number that you get, and the standard deviation is how much you had to add or subtract to get to the next number. So looking at this, what is the mean repair time for the auto shop? So we're going to look at that middle number. This is my mean right here. And that middle number is 102. And specifically 102 minutes, but we're just going to say 102. And then it says, what is the standard deviation? Well, this right here is 1 standard deviation away from the mean. How did I get from 102 to 120? So I can take 120 and subtract 102. And if you want to do that, you're more than welcome to. To get there, I added 18, which means my standard deviation, and here, again, I'm going to abbreviate it as SD this time, is 18. Let's double check that the same thing happened on the other side. So if we take 102 and we subtract 18, we should get 84. I'm going to show you how that double checks in the yellow calculator. So 102 minus 18 should give us 84, and it did. So we're all good. So our standard deviation is 18. Now, what percentage of car repairs take between 84 and 120 minutes? Well, let's look at the percentages between 84 and 120. It's 34% and 34%. So what we're going to do is we're going to add those up, and you're going to get 68%. So the percentage of car repairs that take between 84 minutes and 120 minutes is 68% of the car repairs. What percentage of the repairs take less than 2 hours? Well, this is all in minutes, so let's first convert 2 hours to minutes, and we get 120 minutes. Now that we have that, which take less than 2 hours? So this is our 2-hour mark, 120 minutes, and I need to add up all the percentages that are less than that. So it's 34 plus 34 plus 13.5 plus 2.35. So we're going to add that up. 34 plus 34 plus 13.5 plus 2.35. And I'm going to get 83.85. So 83.85% of the repairs take less than 2 hours. Okay, what percentage of car repairs are between 84 minutes and 138 minutes? So we go from 84 to 138, and we're going to add up these percentages, which is 34 plus 34 plus 13.5. 34 plus 34 plus 13.5 gives us 81.5. So 81.5% of the car repairs are between 84 and 138 minutes. Okay, this is where it gets a little interesting. If the shop did 200 repairs this week, approximately how many of them took more than 2 hours? So first we need to know what percentage is more than 2 hours. So this is our 2-hour mark. Remember, 2 hours was 120 minutes. And we have 13.5 and 2.35. So we're going to add those up, and when you add those up, you get 15.85%. Now, if you have 200 repairs, I need to know how many repairs is 15.85%. So to find that, we're going to do 200 times 15.85, but it's going to be 0.1585 because I had to change this percentage, so I moved the decimal over twice to the left. And when I do 200 times 0.1585, I get 31.7. And it says approximately, and you can't have a partial repair, so we're going to round up. So it's approximately 32 repairs. I want you to try F, so pause the video right now and try F before you go on, because this is going to be the last question we do. We're not going to get to example 2. Or sorry, we are going to get to example 2, but this is going to be the last question we do on this. So if the shop did 300 repairs this week, approximately how many of them took less than 84 minutes? So 84 less than that, we're going to go to the left side, is 13.5 plus 2.35. We already know that equals 15.85%. So now we need to do 300 times 0.1585. Again, we change that percentage to a decimal. And we put that into our calculators. And we get 47.55. Again, we're going to want to round up. So it's 48. And the reason we're rounding up is there's a 5 after that 7. So 47.55 rounds up to 48. Okay. Now, we're going to sketch a normal curve for the following distribution, and we're going to go within 3 standard deviations of the mean. So first, we're going to sketch our normal curve. I'm not the best at sketching, so you don't have to be either. The middle is your mean. So my mean is 45. We're going to put 45 right here. And then a standard deviation of 5. So we need to go 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away. So we're going to add 5 to 45 to go up, which means this is 50, this is 55, this is 60. And then going back the other way, you have 1 standard deviation away, 2 standard deviations away, 3 standard deviations away, but we're subtracting this time. So it's 40, 35, 30. So make sure that you understand how we got those numbers. We added the standard deviation to go to the right. We subtracted to go to the left. Okay, I'm going to show you very much at the bottom. I want you to try this right now. Pause the video. Try this so that you know if you are able to do this by yourself. Giving you a second to write down the numbers. Pause. Try this yourself. Okay? You should have done that by now. This would have been your answers for the you try. You start at 60, you add 15 to go to the right, and you subtract 15 to go to the left. We always want to show 3 standard deviations from the mean. All right. There is an activity for you to do. I hope you have a wonderful day.